It's time you stop struggling with the broken handshakes between your front-end and back-end, because today we are building a production-ready authentication system using the golden standard, Next.js for front-end, and FastAPI for our high-performance back-end. And we are not just going to implement a hello world, we are implementing JSON web tokens, secure password hashing, and Axios Interceptors to ensure every result from your Next.js app is authenticated. Now, join me in this tutorial as I teach you how to perform authentication with your Next.js application and your FastAPI backend. This is one of the quickest authentication you can set up, and you actually don't need to pay for a subscription. You don't need to pay for a service to do authentication for you. You're going to create this authentication from scratch, and it's absolutely free. So let's dive in and let's write the code for this great application.
To get started, what I would like us to do is to create a virtual environment, set up the virtual environment, activate the virtual environment, and install our requirements. To do that, I have my terminal open, and I'm going to do this in my CLI, my command line interface. I have accessed my current directory, the directory of my project, the root directory of my project. Make sure you are in your root directory, and you can see my root directory is in the desktop, and this is my file that I want to have my application. And this application is going to be divided into two. We're going to have our backend and our frontend. And I'm going to get started working on my backend. And the first thing I'm going to do in my backend is that I have to have a Python virtual environment to work with. So to do that, how I create the virtual environment, how I go about this is I'm going to have I'm going to first of all create the backend directory, and it's going to be make directory, and you're going to make the backend directory just like that. And then after making the backend directory, we're going to access the backend directory just like that. And then we are going to activate the virtual environment. But how are we going to activate the virtual environment without even having the virtual environment? So we need to create the virtual environment folder first. To do this, we say Python m venv, and then we give this a few seconds to have a virtual environment folder created. Now that I have my virtual environment created, I'm going to go ahead and activate the virtual environment. And how I do this is by running venv. Then I'm going to have the scripts. Then I'm going to have the activate. Just like that, you can see the virtual environment is activated. And these green parentheses, and you can see the green text venv, meaning that we are in our virtual environment and it's active. So I'm going to have all my requirements installed with this virtual environment activated. Make sure when you install anything, any dependency, any library, you have your virtual environment activated. It's going to even make it easier when deploying. So we're going to work with the virtual environment, and the first thing that I want us to do is to install our requirements. To do this, I'm just going to open my Visual Studio Code and write the requirements.txt. In your root folder, your root project folder, create a requirements.txt. Create a requirements.txt. Just like that. Let's define our libraries and our very essential dependencies. These are essential libraries for JWT and for password security. So the first one is FastAPI, obviously. The next one is UVCon. And in square brackets, have this set to standard. The next one is Python JOS. And in square brackets, have this set to cryptography. Cryptography, did I spell that word correctly? Let me just check for the spelling, and quick fix, and cryptography, just like that. And passlib, and in square brackets have your bcrypt here. And then I'm going to have my Python multi-part. Then I'm going to have my pedantic settings, just like this. Now these libraries are essential for authentication, running our FastAPI, password hashing, and basically the Auth system and running the FastAPI. We have the UVCon library to run our FastAPI. To start it up, we have our FastAPI, the actual backend that you're working with. We have the Python JAWS for cryptography, for hashing the password. We have the passlib, also the same purpose. So to integrate our database layer into our authentication system, we need to bridge our SQLAlchemy models with the FastAPI security logic. And then we configure Alembic for the migration. So for the database, just going to write here that for database interaction, I'm going to have obviously SQLAlchemy. You can already guess you're going to work with this OM or ORM, and you're going to have the Alembic, and then you're going to have the Psycho PG2 binary, just like that. Now, after saving my requirements, I'm going to install my requirements. So it's pip install the R flag and requirements.txt. I'm going to give this a second to install, and then we can now start working on our backend application. So in our project, we are going to work with Neon to host our PostgreSQL database. And Neon is an open source database. And this way we are going to have our PostgreSQL database being hosted. I work with Neon because I think it's easier to set up, less configuration, and you get your database URL in less than 30 seconds, which I usually find to be quite amazing. And it's quite a pro for me when it comes to working with Neon. So we're going to set up our Neon database. Just go to console.neon.tech or visit neon.com, and you'll be able to create your first organization. If you don't have any, sign up, register, get an account. And when you get an account, create your first project and name your project. So my project name is going to be Next Fast API Auth. And then I'm going to have my cloud provider. You can just leave everything as a default. Just give this a name. Create your project. Then you come to this dashboard. You come to your console, and you can see this button called Connect. Right here, you can see the branch, the compute, and all that. It's very fast, and it also has a cheap offers, and it's quite cheap to work with. This is a free trial. You can create as many projects as you want. You don't really have to pay for anything unless you get to a point where you have very many users. That's why I like working with Neon. One of the reasons why I like working with Neon. So I have my database, I have my role, and you can see right here, I have this drop down. Here you can choose another framework, you can choose another language, you can choose another framework to work with. You can choose Django, and you can see the configuration to start. But we are working with SQLAlchemy to connect to our FastAPI backend. So what I'm going to do is I'm going to just copy the virtual environment key, and I'm going to copy my database URL, and I'm just going to copy the snippet, and then I'm going to post this, and I'm going to copy this and just have it in my virtual environment file. So very quickly, I'm going to come to my venv. I'm going to create a .env file, .env. And then right here, I'm going to have the database URL like that. And I'm going to paste in my database URL. And now let's go ahead and create our database.py. to do the migration and to be able to communicate with our Neon database. So let's now create the file that bridges the gap and now connects our backend with the Neon SQL and the PostgreSQL. We'll be setting up our database, connecting our database, and creating our async driver. So we're not going to be building modern APIs with ancient blocking database connection. If we are working with the PsychoPG2 library and FastAPI, we are literally putting a stop sign on our high performance application to handle concurrent processes if we decide to work with a sync database. So our database is going to be async. We are talking about async PG drivers, pedantic configuration management, and the trickiest part of all, we are going to be configuring Alembic to handle asynchronous migrations without even breaking a sweat. I'm going to hold your hand through every single file. No magic skipping. Let's build this together. So to get started, I want to create an app directory in my root folder. And I'm going to name this app. And then right here, I want to have an init.py. This file is completely empty. And we're going to have a config.py. So in our .env, we have this variable, the database URL. And also in my app, to show you an example, in my app, I'm going to create the file that is going to have our database connection set up. And this file is going to open our engine. You're going to see that in a minute. So what happens if I want to use the database URL in my database.py? Obviously, I'm not going to hard code this secret. I have to go ahead and import the, I have to go ahead and import the OS. I have to go ahead and import the OS. And then I have to come here and have the from.env. And then I'm going to import load.env. Then now I'm going to come load.env and like that. And then I'm going to come os.get env, and then I'm going to get the environment variable, and then I'm going to come here and have my database URL. All this process is now replaced with our config.py. We no longer have to load the .env in every single file that we need to use our database URL. Let me show you how we are going to have all of our secret variables defined in one file with type safety. And thanks to pedantic settings, we can be able to achieve this. We are going to be working with pedantic settings. This library is a lifesaver because it reads your .env file and validates the data types automatically. So I'm going to come to my config.py and we are going to create these together. So from the pedantic settings, if you copied what I had in my requirements.txt file, you are sure to have this library installed. I'm going to import the base settings, and then now I'm going to define my settings class as simple as this. And then now I'm going to inherit from the base settings, and I'm going to come here and just define my database URL just like this. My database URL just like this, and it's a type of a string. Now we can read the database URL from our .env file, but we need to tell the settings where our database, our environment, our secret environments are located. So we are going to come here and also create a class config, and we are going to tell our settings configuration where it should read the secret environment variables. So I'm going to have the env file right here, and it's going to be .env, just like that. And then anything that we do not define in our settings class and is in our .env file will be ignored. So I'm going to have the ignore, I'm going to have the extra, then I'm going to have ignore the extra, just like this. So I can go ahead to define other variables that I'm going to have in my secret environment right here, such as the secret key. Then I'm defining the type, and then I'm going to have a default of secret key here. So what this settings class is going to do is going to read our secret environment variables, and is going to copy that and mimic them. So we are going to be holding all of our secret variables in our settings class. This is amazing as it reduces the workload and it makes this reusable and it offers type safety. So here I've provided a default, meaning that this secret key is not needed to be in the environment in the .env file, meaning that this is an optional key. For the database URL, it's supposed to be there, it's mandatory. So if the settings class goes ahead to read the .env file and the database URL is missing, it's going to throw up an error. So let's see how we work with this. So I'm going to go ahead now and create my database URL, my database.py, which is now going to enable us to connect with our database and talk to our database. We are building a production grade asynchronous database. We are talking with async PG drivers. The aim of our database.py is to be able to talk with our asynchronous Postgre database and connect with it seamlessly. How does FastAPI safely talk to a PostgreSQL database asynchronously? So that we have a fast engine, so that we get quick responses with our FastAPI and we don't block any concurrent operations from multiple users. Let's go ahead and solve this. So I have my database.py open like this. I've already defined my config.py, and this is where we are going to load our database URL. So let's instantiate it once and use it everywhere. I'm going to come to my database.py and I'm going to have my imports at the top right here. Having my imports defined like this, I can now go ahead to write my code block. But what is really happening here? We have the create async engine, which you have imported from the SQLAlchemy.x.asyncio. This creates an async database engine. This is the core object that knows how to connect to Postgres. And then we have the async session, represents one database connection. And then we have the async session maker, a factory that creates sessions when needed. And then we have the declarative database right here from SQLAlchemy OM. This is the foundation for all our OM models. And then we import our settings from our .config. I have instantiated this settings class once right here, and then we can use it throughout all our code whenever we need it. So I've just imported these settings from the config. And now I'm going to configure my database URL, or rather modify my database URL to work with our async PG drivers. So let me define my DB URL. So my DB URL is going to be the settings and then the DB database URL. You can see the type support, you can see the autocomplete, all because we are using the base settings with our settings in the config.py. And you can see how I get the autocomplete and the type safety thanks to the pedantic base settings and defining our variables in the config.py. So now I'm reading the database URL. This pulls something like this right here. It pulls this DB URL, but this DB URL is not configurable. It's not okay to work with our async PG drivers. There are some things you are going to modify. So right here, there is a problem. We need to modify this URL so that it can know we are working with async PostgreSQL. So that's why we need this function right here. And I'm going to define the function, and it's going to be get async PB URL, just like that. It's going to return a string. So FastAPI and SQLAlchemy async mode does not work with the normal PostgreSQL. It must use PostgreSQL plus async PG, just like that. But we are not going to modify this in our .env directly. Let's modify this in our database.py. So I'm going to delete this. I'm going to delete that snippet. Then I'm going to come here. And first of all, I have to check whether we have the database URL being read. So if the database, if we don't have the database URL, we are going to raise a value error, and it's going to be database URL has not been set up. So we have checked if we are missing the database URL in our environment. We are just safe checking this because it's already been checked in the config.py. But just to make sure, let's ensure that we have the database URL being loaded. And then for the first modification, I'm going to do this. If we have a question mark in our database URL, in DB URL, you're going to go ahead and do this. You're going to have the base URL. You're going to get the base URL now. And it's going to be the DB URL. And it's going to be dot split. You're going to split at the question mark. Anything that comes after the question mark will be eliminated. Else, the base URL is going to be equals to the DB URL, just like that. Why do we do this? Neon often adds params like this. The SSL mode require and the channel binding require. This has been added by Neon right here. And this is what comes after the question mark. Alembic plus SQLAlchemy async engines hate malformed URLs. So we strip them temporarily just for safety. So after declaring my base URL, I'm going to go ahead and just have, I'm going to go ahead and check if the base URL now starts with the PostgreSQL, and I'm going to have the async DB URL now being equals to base URL dot replace this PostgreSQL with PostgreSQL plus async PG, just like that. I'm going to have an else right here. Else, we're going to have the async DB URL being equals to this URL. So this is very critical. You see right here, we are replacing the PostgreSQL, the starting line right here, the PostgreSQL. We are replacing this with the async we are replacing this with the PostgreSQL plus async pg. This single line is what enables true async database access. So I'm just going to go ahead and just return the async db URL, just like that. This is how we define our function to get our async database URL. Now let's create our engine. So I'm going to go ahead and create my engine, and it's going to be create the async engine, just like that. I'm going to open the parentheses and I'm going to get the async db URL. I'm going to get my configured URL and my modified URL, and then I'm going to echo this to true to make sure that it's been loaded and it's configured the right way, just like that. So what this engine does, it manages connection pooling, it knows how to talk to async, it knows how to talk async to Postgres, it knows how to communicate with Postgre asynchronously. The echo true logs SQL queries, which is great for our debugging and knowing where we have gone wrong. Think of the engine as, I know where the database is and I know how to reach it. And now let's create the async session factory. So I'm going to have async session local. So this might be a little bit confusing and intimidating, especially if you're just beginning to develop with FastAPI, or you're just starting to use SQLAlchemy, or you're a beginner. It might be a little bit intimidating, but don't worry, you get the hold of it as we progress, as we make more function, as we continue to use this database over and over again throughout our code. So we have the bind, and then we are going to pass the engine that we just declared here, and we're going to have the class as the async session. Then you're going to have the expires on commit, and then you're going to have this set to false. Why does this matter? Every request gets its own session. It prevents shared state bugs. The expires commit on commit is equals to false keeps object usable after the commit. This is the FastAPI save session handling right here. And now I want to declare the base model, and it's going to be the base declarative, the declarative base, just like that, just like that. Every model that you're going to create, when defining our user tables, we are going to be using this model, and all of our models are going to be inheriting from this base model. Alembic is also going to later use the base.metadata to detect the tables and to generate the migration. And now let's create the dependency injected DB session, the function that you're going to inject as a dependency to our route paths when we are creating our routes with FastAPI. So we are going to be injecting this function as a dependency, and it's going to be the async method, which is going to be called get async database. We're going to be injecting this function as a dependency in our route paths when working with FastAPI. So this is where FastAPI magic happens. So let's have this async with async session local, async session local as session. Let's yield the session. So it's going to be a dependency, and it's going to be injected as a dependency in our route path. So now, how do we describe our database structure so that SQLAlchemy and Alembic can understand it? This is where we create the models.py. So inside your application directory, your app directory, have the models.py defining our tables. This file is where we define what tables exist and what columns they have. And just a disclaimer, we are not writing SQL, we are describing tables using Python classes. So quickly, I'm going to have my imports. What do I need to define a table? So I'm going to have from SQL Alchemy, I'm just going to import the column, integer, the string, the boolean, just like that. And then from my database file, I'm going to import the base. So the column represents one column in a database table. And then we have the SQL data types, which maps this to the PostgreSQL types. So the SQL Alchemy maps these to PostgreSQL types. And then we have the base, and this is the declarative base that we just defined in our database.py. This is the ORM base class, the ORM base class. Every model must inherit from this. If a model doesn't inherit from the base, Alembic will ignore it completely and will not be able to perform any of our migrations. Let's go ahead to define our first class, and it's the only class that you're going to have in this models.py, and is the user class, and it's going to inherit from the base, as I said. This line means this Python class represents a database table. So the user is the Python name, table comes next. So let's have the table name, the explicit table name. So it's going to be table name. It's going to be the users, just like that. SQL Alchemy could auto-generate this name user, but explicit is better than implicit. Keeps naming predictable across migration. So in our PostgreSQL, this is the name that will be given to this table. It's going to be called users. So I'm going to go ahead now and just define my columns. So we have the ID, and it's the primary key, and the ID is going to be a column. It's going to be a column. It's going to be an integer. It's going to be a primary key, which is a true. And then you're going to have the index, also going to be an index field, which is a true. And then I'm going to define the email, which is also a column. It's going to be a string. It's going to be a unique of true. It's going to be a nullable of false. So this is required. The new user entity cannot be created in the database without having the email. And then we are going to define our hashed password. So right here, let me just explain a bit. We have the string is going to be stored as a varchar in Postgres. Is going to have a unique of true. So we cannot have two users having the same email. And then the index true is going to is also going to have the index of a true. So I want to have the index true just right here. So this is for faster login queries, and then you're going to have it as a nullable of false. It must exist. This is what enforces one account per email at the database level, not just in code. And then now we have our hashed password, which I'm just going to define here. The hashed password, which is going to be a column. It's going to be a string, obviously. It's going to be a nullable of a false, just like that. So obviously the user cannot be created without the password. and we cannot store a plain password. For security reasons, we have to have our password stored as hash. And then we have the last field, which is very simple. Is going to be the is active, our last attribute here, and this is going to be a column, and it's going to be a boolean. So now instead of completely deleting a user, we just keep the information and we deactivate them, and we keep the relations to avoid breaking the app. So now let's create our Alembic, initialize our Alembic. So currently I'm reading the Alembic documentation, the Alembic setup, and what Alembic really does. This is all found in the documentation at this URL, the alembic.sqlalchemy.org. You can visit their documentation, you can learn more about Alembic. Alembic provides the creation management and invocation of change management script for a relational database using SQLAlchemy as the underlying engine. This tutorial will provide a full introduction to the theory and all that. So first thing I want you to note is that Alembic is not the ORM. Alembic is not the ORM, if I might say. Alembic works on top of the SQLAlchemy. The main engine here is the SQLAlchemy, but Alembic is used to perform the migration. And usage of Alembic starts with creation of the migration environment. This is a directory of scripts that is specific to a particular application. So the migration environment is just created once and is then maintained along the application source code itself. And I want you to note the structure of the environment. When we initialize Alembic, we are supposed to have an alembic.ini. We're not going to have this pyproject.toml. We're going to have the Alembic file. The directory includes these files, the alembic.ini. So whenever we're going to run the initialization of the Alembic, we are going to have this file, the alembic.ini. We're not going to have this. This is optional. This is not for all the projects, but most modern projects have a pyproject.toml file. Alembic may optionally store projects. So this is optional, but you're going to have the Alembic directory. And inside the Alembic directory, we are going to have these files. Very important. We are going to have the versions file and the .env, which are the most significant files. And to get started, we can read the installation right here. We already activated our virtual environment. As you can see, you have to create a virtual environment, activate the virtual environment. We have already installed Alembic. So what is remaining is going ahead to initialize Alembic. The install will add the Alembic command to the virtual environment. All operations with the Alembic in terms of this specific virtual environment will then proceed through the usage of this command. As in, the Alembic initialize Alembic, the Alembic init Alembic. So let's go ahead to initialize Alembic and create our files for Alembic to work with SQLAlchemy. Documentation, we have already done majority of the work to have Alembic installed, to have Alembic in our virtual environment, to have Alembic library installed. And now I want us to initialize Alembic in the right way. As we read in our documentation, we need to initialize Alembic, and we saw that we need to have some folders in order to work with Alembic. Now we need to configure Alembic to work with our asynchronous SQLAlchemy, and we just saw that Alembic is just an engine built on top of the Async SQLAlchemy which you are using. And normally SQLAlchemy is not usually asynchronous, it's usually synchronous. But we decided to have our SQLAlchemy to be asynchronous in order to work and handle concurrent operations from multiple users and not have any blocking database connection, and in order for our engine to be much faster. So I want to initialize Alembic the right way to work with our sync drivers. And before even initialize Alembic, I want you to have the async pg driver installed in your virtual environment, in your environment. So when my virtual environment is activated, make sure you have the virtual environment activated. Scripts do this in my Windows. On my Windows is a venv, and then I have the scripts, and then I have the activate, just like that, to have the batch environment activated. Now I'm going to install the async pg drivers. Pip install async pg, just like that. I'm going to have this installed just like that, and it's already installed. So make sure you install the async pg library. Now let's initialize Alembic, and it's going to be Alembic init, and then I'm going to have the async template for async Alembic, and just like that, I'm going to have my Alembic initialized. You see that I have created a new Alembic folder. You can see the Alembic in A already created. So the init creates the Alembic folder, and this template flag for async tells Alembic this project uses Async SQLAlchemy. And then we name the migrations directory to be Alembic, and this gives us this file right here with the env.py and the versions, which is an empty folder, and the env.py and the Alembic in it, just like that. Now we need to configure some few things in our env.py in order to work with Alembic and have Alembic be aware of our tables, the tables that you've just created, and we've just written the code that you've just written in our models.py. So another question you might ask, why didn't we run the normal Alembic init Alembic? Well, what we would have gotten if we run the normal Alembic init Alembic, we would have gotten async engine, async db, async database assumptions, and we would have worked with psycho pg style behavior. And this will not work correctly with our FastAPI async routes, our async postgre, and our create async engine function in our database.py. So the async template is non-optional in this stack. So you already pasted the default async env.py right here, and 90% of this is correct. We only need to change specific targeted path. We are going to modify only what is necessary in this file. You're not going to rewrite the whole file. So from this section near the top, from Alembic import context, below it, I want us to have this code, and I'm going to import my system. I'm going to import the OS, just like that. And then I'm going to have the system path, system.path, and then I'm going to have the append. Then I'm going to open the parenthesis and the OS path, and I'm going to join and the OS path, and then the directory name, and then I'm going to have it to be our file. And then outside of this parenthesis, but inside of our OS path join parenthesis, I'm going to have 2 dots, just like that. And then I'm going to say I'm now going to have my local imports from app.database. You're going to import the base, the uppercase, the base. Then you're going to get the async database URL, our configured database URL, which works with our async pg drivers. And then from that, and then again, you're going to have from our app.models. We are only going to import our only table, which is the user table, to make Alembic aware of our tables, and in order for the migrations to happen as they should, so that Alembic can go ahead to compare the tables in the actual database with what we have in our code, just like that. Now Alembic runs outside your FastAPI app. It cannot see your models unless you add the path. That's why we're importing the user, and importing the user ensures the model is registered on the base metadata. If you don't import the models, Alembic will generate completely empty migrations. So Let's now go and change the source part of this env file. This is the source part. This is the most important part. This is where everything is defined. This is where Alembic gets to compare your tables and your code with what the tables in our actual database that is hosted by Neon. Right here, you're going to change this from none to base, the declarative base that we just have, and you're going to say base metadata, just like that. And this line answers the simple question that is the key question in this file: which table should I track? Now, Alembic can detect the user table, detect future models, auto-generate schema changes with this change we have made right here, and find this line near the top, the config equals to context config. Immediately after it, let's add config main, set main option, set the main option. I'm going to open the parentheses, and then I'm going to have the SQL Alchemy URL be our database, our modified database URL. So it's our get async, our modified async URL, which is just put it right here, which is supposed to return the modified URL to work with our async pg drivers. Just like that, it's a function supposed to return our modified URL to work with our async drivers. So we don't want Alembic using alembic.ini. We don't want it using this file. We want it to use our .env file. We must use the database URL because this guarantees the same database as our FastAPI, same async driver, and no mismatch between runtime and migration. Now, if you don't really get this, don't worry, just make the major changes, and you can go ahead and copy this file, the alembic.env.py, and just paste it. So we don't modify any of these functions. We don't modify any of these functions because the async template already handles async engines correctly, bridges the async sync internally, uses async pg safely. The async template is already battle tested. We only wire it to our application and our setup. As simple as that. Now what I want to do is go ahead and run my first migration, and when I come to my database right here, as we reload these, when I reload these tables in my Neon console, you can see I have no tables currently, 0 tables in the public schema. So when I run my first migration, these tables should appear in our Neon console. So to do this, I'm going to clear this, and to do this, I'm going to make sure that I have my virtual environment activated, and I'm going to create my first migration script, which should appear in our versions folder. Take note of the versions folder. It's completely empty for now, but when we create our first revision script, there should be a file in the versions folder. So I'm going to run Alembic, and then you're going to have the revision, and then I'm going to have the auto generate, and then I'm going to have the message as initial users table, just like that. Now I'm going to press on enter, and I'm going to wait for this script to be created. And now I have my script created in my versions folder, in the Alembic folder, and here you go, you get your script. And now let me now run the final command to have this appear in our database. Is Alembic upgrade is going to be head, just like that. Just like that, we have the async engine created, async pg is used, migration is run safely, and now we have our table created. We have our migrations made, and we have successfully been able to set up our database. So when you're building our Auth for our backend, we'll move in 3 layers because that's how real backends are built. We have the password hashing, which is the security foundation. The auth crud, database logic. Auth crud is auth and the crud operations, which are the create, read, update, and delete. We have the Auth endpoints. These are the fast API routes. No skipping any of these steps. Before any Auth logic, we answer these questions. How do we store passwords safely? So, the rules that we have here: never store raw passwords. We all know that. Never compare raw passwords. We have to always hash and verify our password when we are going to be creating our authentication system, right? So we're going to create a small dedicated file inside our app. We're going to call this file security.py, just like that. And inside our security.py, I'm just going to show this route to my app, to my file. I'm going to have this route right here, security.py. I'm just going to declare the route to my file right here. So the first thing you're going to import right here at the top is from the parslib contexts. You're going to import the crypt context, and then we are going to have the password context right here, and then you're going to have the crypt context. Then you're going to open this. So I have a typo. It's the crypt context, just like that. And now inside here, I'm going to have the schemes. You're going to have the bcrypt. Then you're going to have the deprecated, just like that. Deprecated. It's going to be auto, just like that. So we're going to come here and have our hash password method. Just like that, and we're going to have the password as an argument, and it's going to be a type of a string, and then you're going to return a string, just like that. Then you're going to have define this password. You're going to return the password context, and then now we are going to hash this password, to hash the password right here, just like that. Then you're going to have the verify password. Then you're going to take the plain password as an argument. Plain password as an argument, it's a type of a string. You're going to have the hash password as also as an argument. Then you're going to return a boolean right here. Just like that, and then you're going to return the password context, verify. You're going to open this. You're going to have the plain password being passed in, and then you're going to have the hash password also being passed in. So the bcrypt is slow to design, but it's harder to brute force. And this hash password function turns the password into a reversible string. And the verify password compares plain text with the hash password safely. And one thing to note is that we never decrypt the password, we only verify the password. And now let's do something. Let's isolate the database operation from our API routes. This keeps our code testable, readable, and scalable. How do I do this? I'm going to have create a new file, call this crud. Then I'm going to have the user crud right here. So I'm going to have the user crud right here. like that. And I'm going to now define my crud py. So inside my user crud, I'm going to just save the security.py. Inside my user crud, I'm going to have the route defined to this file. It's a nice practice to always define your routes to your folders. So I'm going to have the app, and then it's a crud, and then it's a user.py, just like that. Inside here, I'm going to have the SQLAlchemy import extension dot async io, and then I'm going to import the async session. You're going to see how now we're going to pass the database that we the get database async database that we defined in our database.py. You're going to see how we're going to inject it as a dependency right here. Then you're going to have the SQLAlchemy. From SQLAlchemy, we're going to import the select. Let me import from the app. Let me import the user model. Let me import from my security app, the security file that I've just created. Let me import all of the functions that I need. So I'm going to import the verify password, right? Verify password and the hash password. Now let's create our user registration logic. So let's create the function that will be creating the user. So it's going to be an async function, an async method, async def, and then you're going to create the user. It's going to be create user. Then we are going to be expecting these things as an argument. We're going to be expecting the async session, the database, which is an async session. We're going to have the email, which is a string. We're going to have the password, which is a string, password as well, which is a string. We're going to have and then you're going to have to return the user right here, just like that. Then I'm going to have the hash password equals to the hash password. This is where you're going to hash the password that you've just gotten right here, and then you're going to have the user now as the user object. You're going to pass in the email. You're going to be equals to the email. You're going to have the hash password in equal to the hashed password that you've just defined right here. So we have hashed the password using the method that we defined in our security file. Then you're going to have the DB, and then you're going to add the user, just like that. And then you're going to commit the user, and you're going to be await, commit the changes to the database, commit the new user, commit the changes to the database, and then you're going to await, refresh this to refresh our database and have the changes, and it's going to be the user. So, and then you're going to return the user. As simple as that, just like that. So we hash before touching the database, just like this. Then we commit the new user to our database. We write the new user to our database, and then the refresh method right here is going to reload generated files like the ID. So we're going to create another method right here, and you're going to call this. It's going to be get user by email. Then what you're going to have here is the database, a type of async session, async. Then you're going to have the email, the string. Then you're going to be returning the user or a none. So if you get the user, we return the user. or if we don't get the user, we are returning a none, just like that. And then now let's go ahead to create the function. So the result will be await the db execute. We're going to select the user where user dot email equals to the email, just like that. You're going to go ahead and execute this query, and you're going to return result scalar 1 or none, just like that. So login is always email based. Index on email makes this to be fast. So that's why we created our attribute to have an index, the email field to have an index in our database. So if the user does not exist, we return a none. I also want to go ahead and create a function to authenticate the user. I'm going to take these arguments. We're going to have the database. It's an async session as well. Then you're going to have the email to be a string. Then you're going to have the password as also as a string. So right here, I'm going to return the user also, or I'm going to return a none. Then I'm going to go ahead and define my function. So user is going to be await get user by email, and then you're going to pass the email, just like that. If we don't have the user like that, you're going to return a none, just like that. If not, verify password. We pass in the password. This is how we verify the user. We get the user hashed password, just like that. We compare the two, just like that. We compare the password and the user hash password, and then we return a none if we don't verify the password. And if the user is not active, we are also going to return a none. We're going to return the user, just like that. These functions answers the question, is this a login validated? If the login is not validated, we return a none. If we get to pass all these conditions, if we get the user by the email, if we verify the password, then we get to return the user object. And here I have a small error. I did not pass the database right here. I'm just going to pass the database just like that. So I've now created the methods, and if we get to do the 3 checks right here, then the user exists, the password matches, and the user is active, we get to return the user. Clean, explicit, and safe. Let's create the auth endpoints. Now we are going to expose the auth logic to the outside world. So to do this, I want to first of all have a schemas.py. Here I'm a schemas folder, and here I'm going to have all my schemas defined, and I'm going to have these schemas and just call this auth py, and I'm going to just have the root right here to my folder schemas auth, just like that. This is my auth schema, and I'm going to start by importing the pydantic. So pydantic is going to be helping us with our type. And one of the reasons why people prefer to work with FastAPI is because of the support type safety offered by Pydantic. So if you want to read more about Pydantic, you can visit their documentation. Pydantic is going to help us define our models. It has already done that by helping us define our base settings. Now here we are going to import the base model, and you're going to inherit it in our classes that are going to define our JSON schemas. So we're going to have the base model, and then you're going to have the email string, just like that. And then I'm going to have the following classes. The class register, this is a type class, so it's a type. I'm defining a type here, register request. What do we expect from the user when they are going to register as a new user? So I'm going to inherit from the base model. What do I expect from the user? I expect an email, and the email is going to be a type of an email string. And then I also expect a password, which is obviously a string, just like that. And what do I expect from the user when they are logging in? Is a class login request. This is also going to import from the base model, and here I don't have a comma, sorry. I'm going to have the base model I'm going to have my class inheriting from the base model. What do we expect? We also going to expect a simple email and a password. Okay, this is an email string, and then I'm going to expect a password, which is also a string. And then why does this schema matters? Because of validation, clear API contracts, and automatic documentation. Now what I want to do is to define our first route, which is our auth py. So also inside my app, I'm going to create my route, just like that. Inside here, I'm going to create my first route, which is my auth py. And whenever you're creating a new folder, we have to always have an empty init file. So I'm just going to create the init.py very quickly for all the folders that I've just created for the crud. So it's also a safety practice to have this init.py as an empty file in our folders. And also for the schemas, I'm going to create a new empty init.py, just like that. So for the routes, I'm going to go ahead and define my auth.py, and here I'm going to define the path to my route that is found in the apps, and then it's going to be the routes, and then it's going to be the auth.py, just like that. So I'm going to start by importing from FastAPI. I'm going to import the API router, just like that. I'm going to import the depends to inject our get async db as a dependency. We're going to have the HTTP exception. We're going to have the starters, just like that right here. Then I'm going to have from SQLAlchemy dot extension dot async io. I'm going to import async io. I'm going to import the async session, just like that. So I'm going to also have my local imports just right here, database. You're going to import the get, the function that you're going to pass as a dependency is the get async db, just like that. And then you're going to have the from app schemas auth schemas.auth. You're going to import the auth, both of the schemas that we just defined, which is the register request and the login request, just like that right here, and then we are going to have from the app crud.user or crud functionality. We are going to import all of the cruds that we just defined here, which is going to be the authenticate user, the get user by email, and the create user, just like that. And then we are going to go ahead and now define the router setup. So to define our routes, we are going to do this. We're going to have the router equals to the API router, and here we are going to have the initializer. We're going to have the prefix. So all of my files in here are going to be initialized with a /out. So if you are calling any endpoint in our auth.py routes, we have to start with the auth /auth path, just like that. Then I'm going to have these as a tags, have these tags b equals to the auth. You're going to see this in the documentation, how this creates a separate category for auth routes. Then I'm going to come here and have this decorator at route slash router at router. Then we have the dot, we have the post first, the post request to register a new user. And we're going to now define the function that is going to register the user right here when the route is called, and it's called the register. And then you're going to have the data as a login as a register data, register request type. And then you're going to have the database as a type of an async session. Don't know why I keep on misspelling that. It's going to be a depends. It's going to be a dependency injection of the get async db. And then we are going to have this function. We're going to define this function. So the existing user is an await of get user by email. So we're going to check if the user exists. Then you're going to pass in the data, the database first, and then you're going to pass in the data, and then the email, just like that. Just like that, you're going to check if you have an existing user. And then if we have an existing user, if we get an existing user, you're going to throw a HTTP exception, and it's going to be the status code is going to be equal to be a status HTTP 400 bad request, and the detail to this is going to be email is already registered. So we cannot register a user twice, right? Because we have to have the email being a unique entity in the database. So just like that, now we get the user, we await, we now create the user with this function that we just defined. And then you're going to have the db being passed in as the database. And now we're going to pass in the email as the data that you get, and it's the data email, the data dot email, and then the password is going to be the data dot password, just like that. Just like that. Now, if in any case we fail to register the user with our create user method, this error is handled in the create user. We have handled the error in the create user. I'm going to save the unsaved files. If we fail to create the user, this error is already handled in our create user method. So right here, you're just going to return the successful user. If the user has been created, you're going to return the ID, which is going to be the user ID. You're going to return the email, which is going to be the user dot email, and you're going to return is active, which is going to be equal to the user is active boolean field. So the user is active, just like that. So we check uniqueness manually before a DB error. We never return a hashed password, and the response is just minimal and safe. So this is a simple function to register our user. I'm going to define my login function. It's going to be a router.post. It's going to be the login endpoint right here. It's going to be an async dev login user, just like that. I'm going to define my data right here. It's going to be the login request. Then we're going to define our database just like that, and then going to be a type of an async session. async session, which is going to be injected as a dependency, which is going to be get async db, just like that. Let me define my function, go ahead to get the user, await authenticate user, just like that. Then I'm going to have the db being passed in as a database. Then I'm going to have the email being passed in as a data email, and then I'm going to have the password being passed in as a type of a data password. Then we are going to check if we don't have the user, just like that. We're going to go ahead and raise a HTTP exception, just like that, and it's going to be a status code of 400 status for HTTP 401, sorry, HTTP 401 unauthorized, and it's going to be a detail of invalid credentials, valid credentials, just like that. So if we don't get the user, we throw up an error of invalid credentials if the wrong password or the wrong email is passed. And then now if we get to bypass everything, right here we're going to return the message. The message is going to be login was successful. Then we're going to have the data, we're going to have the user ID, then we're going to have the user dot ID, we're going to have the email as user email, just like that. At this stage, we are not issuing JWTs yet. This is intentional, so we are going to issue these later. We are now done defining our routes. We have created our routes, we've created a crud, we've created the schemas.py. We've gotten to this point, nice job. Now we have the basic request flow for our login and authentication. The client sends the email, the password, FastAPI validates the input using the Pydantic, the dependency injects the async db session, the crud verifies the credentials, the password hash is checked, the user is returned or rejected. So this makes JWT easy to add later, the OAuth easy to plug in, testing straightforward, and now we can easily test our OAuth flow. So next you're going to create the JWT access and the refresh tokens. And to do this, to get started with implementing our JWT refresh and access tokens, so that when a user log in, they get back the refresh and access token, I'm going to open my terminal and I'm going to have my virtual environment activated just to confirm that you have the library. Let's just install these libraries again. It's going to be pip install, and then I'm going to have the JOS, the Python JOS. Don't know whether I'm pronouncing this correctly. Python JOS, and then in brackets, in square brackets, you're going to have the cryptography, just like that. And then I'm also going to have the passlib, and then into square brackets, I'm going to have the bcrypt, just like that. Then I'm going to click on enter and have these libraries installed. And I already have the libraries installed. It seems like I already have them installed. So the last time we did our installation of the async pg, we forgot to freeze our requirements. I'm going to freeze my requirements.txt again to make sure that I have them updated with the latest dependencies and libraries. So I'm going to have the pip freeze, and it's going to be the pip freeze greater than sign, and then it's going to be requirements.txt, just like that. And now what I'm going to do is that I'm going to come to my config.py. just like this. And I want to have some new keys here that you're going to work with our bcrypt library, our Python JOS library, to do the hashing and to basically create the JWT tokens. So the JWT secret key is going to be a secret key which you have not created yet. You have to create this, and it's going to be mandatory. It's going to be a type of a string. Then I'm going to be having the JWT algorithm for the hashing. This method will define how we do our hashing and how we create the secret key. And this is going to be algorithm. I've misspelled this, algorithm. And this is going to be a type of a string as well. But this one we have a default of a H256, which we're going to be using as the JWT algorithm method. And then we have the access token expire. Then we have the minutes. Then we are going to set this to an integer, and let's do this as an integer, and let's do this for 30 minutes. We're going to have this access token fresh for 30 minutes, and then we're going to have the refresh token, and then it's going to be the expire days, and it's going to be an integer, and this is going to last for 7 days, just like that. I'm going to still have my class config right here the way it is. So I'm going to save this, and the next thing to do is now go to my .env file and create this JWT secret key, just like that. You can go ahead and create a secret key that you will only be aware of as the developer, and you're going to have this stored obviously in our secret environment variables file. But you can create a key, just have anything. But in order to be secure and safe, and to make sure that hackers cannot find a vulnerability in your authentication system, I recommend that you follow what I do. So you can have this key to my secret whatever, and have some words and set it to anything. But I'm going to generate a secret, and I'm going to do this with my terminal. So I'm just going to come here and write this Python code, this Python C flag for the code, and then I'm going to have import secrets. And with the secrets library, I'm going to have a new key, and it's going to be print secrets, and it's the token hex of 32, just like that. And I'm going to have this as my Python generation for the secret JWT secret key. So I'm going to click on enter, and then I have generated my key like this. I'm going to copy this key. You can just do the same. Have this code snippet and run it in your terminal to quickly generate a very strong key that cannot be guessed, generated by the Python secrets library very quickly. So I'm going to copy this right here and just paste it as my secret key right here. And then I'm going to clear the terminal again. I'm going to close the terminal. And then now in my root directory, in my app directory, I'm going to create the jwt.py file, jwt.py, to help us generate our access token and our refresh token. And I'm going to have those two methods, one method to generate the access token, the second method to generate the refresh token. So I'm going to have from datetime, I'm going to import the datetime object, and then I'm going to import the time delta, just like that. And then from the JOS library, I'm going to import the JWT from the JOS JWT, just like that. Now from the app config, we're going to import our secrets, obviously, just like that. And now our settings. And now I'm going to create the function to create the access token, a function that is supposed to create the access token. It's going to be the def create access token subject, We're going to take the subject as an argument. It's going to be a type of a string, and we're going to return a string just like that. And then I'm going to have the expire defined to date, time, now, UTC now. Let's use the standard time zone UTC now, just like that. Then I'm going to have the time delta of the minutes set to the minutes that we defined in our settings, which is the access token expire minutes. You can see the autocomplete. We're working with the base settings with Pydantic, and then you have the payload. I'm going to prepare the payload to have the sub as the subject. So this is like building our own authentication from scratch. So we have the sub as the subject, and then we are going to have the expire, short form for the expire. I'm going to have the x as the expire, and then we are going to have the type as the access, just like that. So we are going to now return JWT encode of the payload and the settings .jwt secret key and the algorithm the settings JWT algorithm, just like that. So with this, I want to now go ahead and also create a refresh token. So I'm going to have another function for creating my refresh token. And this is going to be named create refresh token. It's going to accept the subject as a string again, and it's going to return a string also, just like that. And then you're going to have the expire being equal to the datetime UTC now, the standard time zone, and it's going to be the expire is going to be equal to the time now plus 7 days. The time delta, opening the time delta, we have the days, and we're going to have these settings dot refresh token expire days, just like that. Then you're going to have the payload defined. The payload is going to have the subject as the subject that we passed as our argument for function, and we are going to have the expiry, which is and this is going to be the settings at the expire that we just defined right here. Then we are going to have the type being a type of refresh, just like that. And then now we go ahead to return JWT encode, and we open the parentheses, we pass the payload, just like that. We go ahead to pass the settings JWT secret key, and then we go ahead to pass the algorithm being equal to the settings JWT algorithm. Now we have defined our create access and create refresh token. methods. Nice. We have defined our JWT PY. Now it's time to create our dependency, our Auth dependency. And right here, I'm making a small error where I'm passing this as a subject. This should be a sub. It should be passed as a sub. The payload should be created, this being a sub, to represent the subject. This is a short form of the subject. I'm going to save this, and I have now created my jwt.py. Let's go on to create the dependency for our auth py. Now, the dependencies layer is the heart of FastAPI authentication, and most beginners or most people starting out with authentication in FastAPI and working with JWT will copy paste it without understanding what is really happening. So I want us to go through a step-by-step guide, building the mental model first, then walking through the code and writing the code line by line, and finally showing how everything downstream depends on this file. So I have created my new folder in my app directory, and I've named it as dependencies. And inside the dependencies folder, I'm going to create an empty init.py file, just like this. That's empty right there. Now let's focus on creating the auth.py, the auth dependency, and I'm going to create another file, auth.py, and now we'll go ahead to write down our code. And let's start by asking ourselves the problem that this file is going to solve. And the problem that this file is going to solve is the problem of knowing who is making a request. So how does FastAPI know who is making a request? Once we move past our login, every request must answer the following question. Is the user authenticated? Is their token valid? Who exactly is the user? Can this request proceed? And we don't want to repeat that logic in every route. That's why we are going to use dependencies. And if you don't know what a dependency is a function that is going to run before each route that can actually validate data, load resources, reject requests, inject values into our routes, even before running anything in the route, even before running any function in the route. Think of this as a gatekeeper, and if that dependency fails, nothing on the route can run. The route will never run. And so this file right here, the app dependencies, this file right here defines our authentication gatekeeper. So we're going to start with the imports right at the top, and we're going to start with from first API. We're going to import the depends, the HTTP exception, the status, and we're going to also have from first API security. We're going to import the OAuth to password bearer, just like that. And then from the JWT library, Python JWT, we're going to import the JWT, which is going to help in decoding our tokens and raising an error when needed, the JWT error. And then from SQLAlchemy.extension extend.async IO, we're going to import the obvious dependency, which is the async session, which you're going to pass as a type when declaring our dependencies for the database. And now, after having these imports, we are going to have our local imports down here. So you can notice I'm separating the imports, the global imports from the libraries and from the dependencies, I'm separating these from the local imports. I'm going to leave a line and just write the local imports. This is where we import our settings, import the settings. This is where we import the get async database, the function that we defined to get our async database, which we're going to inject as a dependency. We created this in our database.py, and then from the app crud user, we're going to import the user crud function, the user get user by email. This is the only function you're going to need to get the user by their email. And so these imports show the dependency chain. And this dependency, this auth dependency is the bridge between the HTTP request, the JWT tokens, and the database users. So I'm going to just define my OAuth2 password bearer for the token extraction. So I'm going to have the OAuth2 scheme just right here, and it's OAuth2 password bearer, and then you're going to have the token URL in auth login. So this line is extremely important because what it does, it looks for this header authorization. This is the header. It's going to have something like a bearer, and then you're going to have the token. So this line here is going to be looking for the token. It's going to extract the token from the bearer. It's going to get the header and extract the token from the bearer. It's going to make it available as a function parameter. What it does not do, it does not validate the token, it does not decode JWTs, it does not talk to the database. It only extracts the token from the headers. So don't make the misunderstanding of thinking that it's going to validate the token or it's going to decode the JWT. No, the only thing it does, it goes ahead to extract the token and make it available as a function parameter. And so why does this token URL exist? This is used for Swagger, OpenAPI documentation, and for OAuth2 UI flows. It does not affect anything to do with the runtime behavior. And now let me define the core function in the whole of this auth dependency, and it's going to be an asynchronous function. Asynchronous function is going to be an async of get the current user. This function is going to accept two arguments, and though both of these arguments are going to be dependency injection. So the first dependency injection that you're going to have here is going to be the token, and this is going to be a depends, and now we are going to define the OAuth2 scheme inside of this right here, and then we are going to have the database, a type of an async session, and it's going to be a depends of get async db, get async db, just like that. So let's pause here and unpack what is happening here. The dependency injection breakdown. So this line right here, this means that the first API is going to run the OAuth2 scheme, like you have defined it here, and it's going to extract the bearer token from our header, and it's going to inject it into the token. And if the header is missing, by any chance, we get a request from the frontend that requires authentication, and the header is missing. FastAPI automatically returns the 401 unauthorized status. You don't write that logic yourself. FastAPI is going to do it. So that's all you have to understand for now. And then we have our database right here as a type of an async session. it opens an async database session, ties it to the request lifecycle, and automatically closes it. So I'm going to have this function start with a try catch block, a try except block. I confuse this with a catch block coming from the JavaScript world. So it's a try except block, and if this code block inside here fails, you're just going to raise a HTTP exception, and it's going to be a status code of a 401. The detail is going to be user could not validate credentials. Just like that. And now I'm going to define the logic inside my try block. So let's have the payload first. And this is going to be a decoded JWT. It's going to be a JWT decode. What we are decoding here is the token. And we are going to have the secret key to verify this, to authenticate this decoding. And it's going to be JWT secret key. And then you're going to have the algorithms. This is an array, but you're going to have only one algorithm that we defined in our settings, which is the H256 JWT algorithm, just like this. After we have decoded our token, I really want to explain what happens inside here. So the first thing is that the signature is verified, the expiration date is checked, the token integrity is guaranteed. And if the token is expired, or if the token is modified, or if the token uses the wrong secret, a JWT error is going to be raised. So let's extract the subject as we defined it when we were encoding our JWT. So when we were encoding our payload with JWT, we had a subject. So that was the email, and the subject is going to be a string, or it's going to be a none, just like that. And it's going to be a payload. After decoding this JWT, we are going to have the payload, and we are going to have the get method, and we're going to get the subject, just like that. And if the email is going to be none, then we are going to raise a HTTP exception. HTTP exception of a status code of 401, just like that. And the detail is going to be invalid token, just like that, right here. So the short form of the subject, claims the identity of the token owner. It's not a secret, but it's cryptographically protected. And if it's missing, we're going to raise this error of an invalid token. So this ensures that no internal errors leak. Client always gets a clean auth failure. Attackers get no hint. And that's why this authentication system is super strong and robust. Now we go ahead to now get the user using the get user by email method. And then we pass the email. And we check if not user or not user is active, we don't have an active user, then we're going to raise a HTTP exception just like that. And it's going to have a status code going to have a status code of 401 of status 401 HTTP 401 unauthorized, and the detail is going to be user not found. User not found, just like that. If we get the user and the user is active, then we are going to go ahead and return the user, just like that. And now we have defined our Auth dependency, and this dependency is going to now inject the user into all the routes, and it's going to skip the rerunning of the auth logic, and it's going to guarantee authentication when we use it in all our routes. So right here, I'm getting an error because I failed to pass the DB, the database, just like that. So I'm always forgetting to pass the database when defining the get user by email, but go ahead and pass the database and the email. These two arguments are needed for the function. So I'm going to save this, and now we have our auth dependency. Now we can pass this in our routes. We can go ahead to get the current user anytime we need to use them in our route and check whether we have an active user. So why does the auth logic belong in the dependency and not the route? The design gives us one source of truth, no duplicated logic, consistent error handling, easy role checks for later, clean readable routes. Routes stay focused on business logic, not security. And so, let's update our auth endpoints to issue tokens when a user is logged in. And this is all going to happen in the login endpoint. I'm going to have some imports at the top right here. I'm going to import from the app JWT, I'm going to import the create access token and the create refresh token. And from the Python JAWS library, I'm going to import the JWT. I'm going to save this, and I'm going to come here to my login endpoint. And what the login endpoint used to do earlier, it only used to log in the user and verify their email password and then return this success message. And that's not enough for real authentication. Why? Because after login, the server forgets the user. Every next request is anonymous again. What our login endpoint should do right now includes authenticating the user, generating the tokens, and returning the tokens to the client. So I have the login endpoint, the login user right here. The function is taking the login request, the JSON schema that we just defined in our schemas, and then we have the injection of the database. The login request ensures validated input. The depends injects a safe async DB session. No auth logic yet, just a setup. We have our function here, the authenticate user, which fetches the user, verifies the password hash, checks if the user is still active. And then by the time we reach the next line, we know this user is real and allowed to log in. And if not, we handle the error cleanly. Right here, we handle the failure cleanly. Now, we do not reveal whether the email exists, and this prevents user enumeration attacks. So right here, we just return a status of invalid credentials. We do not confirm whether we have an email or not. This is an important point. You don't reveal whether the email exists. And then after this liner right here, after this block of code, what I want us to do is go ahead and define our access token and our refresh token, which will be returning to the user once they're successfully logged in. So I'm going to just create my access token just like that, and it's going to be create the access token. And then what I'm going to be passing as my subject is the user dot email. Same here, the refresh token is going to be the create refresh token. And then what I'm going to be passing as subject is still the user email, just like that. Why do we work with the user email as the subject to create our tokens? Well, the email is unique, the email is stable, and the email is easy to query. Remember, we put this as an index. When we were creating this field, when we were creating the users table, we had an email as an index field. So it's easier to query, it's stable, and every user has a unique email. Now, what's inside the token? The token is going to have the user identity, which is the subject, which we pass the subject, which is our email. We're going to have the expiration date, which is an exp, a short form of the expiration date. We're going to have the type, whether the token is an access token or a refresh token. We're not passing things like the password, that is sensitive data. So after doing that, what I'm going to return here is not a message. I'm going to be returning the access token, which is going to be equal to the access token, just like that. I'm going to be returning the refresh token, which is going to be equal to the refresh token, just like that. And then now I'm going to be returning the token type, and our token type is going to be a bearer, just like that. Let's define our refresh token endpoint. This refresh token endpoint is going to accept a refresh token, verify the refresh token, and then issue a new access token. It does not require any credentials. So let's go ahead and define this. Is a router posts refresh, just like this. Right here I'm going to have my async def refresh token, just like that. We're going to accept a token as a string, just like that. And right here you're going to decode the payload. So you're going to go ahead and define the payload as JWT decode, and then we have the token right here. We have the settings JWT secret key. We have the settings JWT algorithm, just like that. And make sure you have your settings imported at the top right here from the core app config. Now we have now decoded the token. We are going to validate the type of the token, and what this method here does, it checks for the expiry date. It checks whether the token was signed by us. It checks whether the token is expired. It checks whether the token has been modified. And we're going to have the token type enforcement. So to do that, we're going to say if the payload get type is not equal to refresh, then this is going to raise a HTTP exception status code 401, then the detail invalid token type. So this is very critical right here. What I'm doing here is very critical. I'm checking for the payload, for the token type. Without this, access tokens could be used to get the refresh token. Security boundaries would be broken. So this line here is very important. After making sure that this is a type of this token is a type of a refresh, we go ahead to get the subject. So same identity, same user. So we define the email right here as the payload get, then we get the subject right here. So same identity, same user, confirm the user using the email. Now let's go ahead to get the new access token just like this. And it's going to be create access token. What you're going to pass here is the subject, which should be equal to the email that we just defined right here. So with this, we've now created a new access token using the refresh token endpoint. Remember, our access token are very short-lived. They only live for 30 minutes. And then we have the refresh token, which stays for 7 days without expiry. So this is a silent relogin. You can think of this as a silent relogin where we do this every time the access token is expired. Every time the access token is expired, this is going to be called. And if now the refresh token is expired, now the user is forced to log in again. So what I'm going to return right here is very simple. I'm just going to return the access token, and then this is going to be equal to the new access token, and then we're going to have the token type again as the bearer. As simple as this. So we have now gone ahead to define our refresh token endpoint. And the next thing I want us to do is have our first protected route. And this route is now going to be using the dependency of the get current user. This dependency that we just defined right here in our dependencies file, we are going to use it for the first time. What makes a route protected? A route is protected when it depends on this function right here, and it cannot run without authentication. So let's go ahead and create our first dependency, our first protected route that is going to actualize our dependency. In my routes, I'm going to also create another file, and I'm going to call this users py, just like that. And I'm going to have my imports right here from FastAPI import API router and the depends, just like that. And then I'm going to come from the app here, and from the app dependencies Auth, I'm going to import the get current user, just like that. And then I'm going to define my router right here is going to be the API router, and then the API router is going to have the prefix of the users, just like this. And then we're going to have the tags passed in just like this. So the tags an array, and then we have the users tags. This is going to create different categories. When working with the documentation, we're going to have the route endpoints differentiated into different categories. So right now, let's now go ahead and have our decorator right here, a router, and then you're going to have the get, and it's going to be me. So it's going to be async def get me, and then right here now we are going to inject the dependency, and it's going to be the current user is going to be equals to the depends, then you're going to have the get current user dependency, just like this. Now, this single line is doing a lot of work. This single line right here, when a request hits the user's me endpoint, FastAPI sees the dependency. It runs the get current user, the token is extracted, JWT is validated, user is loaded from the database, and then the current user is injected. The route executes. If any of these fails, then the request stops and the route, nothing in this method, nothing in this route is going to run. So you're now going to go ahead and return the user. So you're going to return the email, the ID, which is going to be the current user ID. You're going to just return the details of the user, the email just like that, and it's going to be the current user email just like that. And then you're going to return the is active. It's going to be the current user is active, just like that. Now we have defined our route endpoint, our protected route, just like that. Now let's go ahead, and now after doing this, I want us to create a file that is going to be assembling all of this. But you can note here that you're not returning a password, you're not returning a hash password, no internal flags, and you are having minimal exposure. Why this pattern is going to scale? Once this is in place, every new protected route is trivial, Auth logic never repeats, and you can add roles later on. Now, the main.py is not where the logic lives, it's where everything is assembled, and this is the file that I'm going to create next. So I'm just going to do that and have my main.py in my app directory. Let me delete this and this right here. So in my app directory, I'm going to have the main.py created just like that, and I'm still going to come here and import from the FastAPI. I'm going to import the FastAPI. Let's import from FastAPI middleware cause. So we are also going to implement the cause policy, and you're going to see how we're going to implement this for improved security and filtering of what you want from our front end. We do this with the cause middleware. And now I'm going to have my router imports just right here from app to import, the auth and the users, just like that. And then now I'm going to go ahead and have my app initialized right here, just like this. FastAPI, and then I'm going to have my title, and the title is going to be FastAPI or Backend. Just like this, I have my title, and I can have a description, and the description is going to be authentication with API authentication API using FastAPI and then Async SQLAlchemy and JWT tokens. I can have something like this as the description. You can go ahead to add many more properties. You can have the debug. There is an option to have the version, all this, but for now I'm just going to have the title and the description, as simple as that. Now I'm going to define my middleware, app middleware, just like that, and then I'm going to have the cause middleware from the import that we just had from so I'm just going to have that, and then now I'm going to have the origins that I want to allow for this middleware, and these origins include the HTTP localhosts, the obvious localhost, which is going to be 3000, just like that. So any request from the localhost 3000, which is where you're going to host our frontend, is going to be allowed. Also, I'm just going to copy this again, and I'm going to paste this inside right here. And now I'm going to allow the imports from the localhost 3001 also. So these are the two origins that you're going to allow for now. Later on, after deploying this, you can go ahead and add your new production domain inside of this list of allowed origins in order for you to make requests to the backend. And then you're going to allow credentials. This is going to be equals to true. Then you're going to allow all methods, just like this. So whether it's the delete, the update, the create, all the crud methods are going to be allowed. The same for all the headers right here, which are going to be the different type of headers. All these are going to be allowed. Just going to have an asterisk right there. And now with this, I have defined my middleware, and this is how we define the middleware with FastAPI. Now what I'm going to do is now include my router. So I'm going to include router. So I'm going to start with the old router, just like that. And now I have my routers included right here. And then I have my router right here included. And I'm going to include the user's router also, just like that. Separate, clean architecture. So you can see this dependency composition, something I really love about FastAPI. Auth routes stay isolated, users routes stay isolated, app stays clean. You can see how simple it is to define a simple middleware with FastAPI. It's very simple, very quick and easy, and you can just set this up with a couple of seconds, which make FastAPI a very efficient and reliable backend to work with. Now I'm just going to have my app router defined here. I'm going to have this decorator, and it's going to be the app.get, and this is how we are going to confirm whether our app is running. So I'm going to call this the root, just like that. And then right here inside, I'm going to return an object which is, or a dictionary, which is going to have the status of status of running, to check on our route health, on our whether our FastAPI is live and it has started. This is what you're going to do. So when we hit the localhost 8000, we should see this message being returned. And I'm also going to have the message right here, just like your first API backend is up and running, just like that. I'm going to save. Now with this defined, I want to go ahead and start my FastAPI. I want to go ahead and run my FastAPI. So I'm having an error right here, and unexpected arguments allow origin. Oh, sorry, this is supposed to be app add middleware. I forgot to have this add middleware, just like that. So sorry. So when I save this, this should be app add middleware. I just defined it as app middleware. That was a bug, and now the error is gone. So with this, now I want to run and start up my server, and I start up the FastAPI with the UVCon. And for that, I have to run this command right here. So I'm going to activate my virtual environment. Now, having my virtual environment activated, so I have to access my backend, and then I have to now activate my virtual environment. Now, having my virtual environment activated like this, I have to run this command to start up the server. So it's uvcon app mid.main, and then I have the app, and then I have the reloader. Now this command is a bit of a headache to run every time. So for this, I'm just going to have a shortcut. I'm going to come here and just have this if the name is equals to main then I'm going to print FastAPI backend is starting, or you can just write the server is starting, and I'm going to run this. I'm going to run this command right here. I'm going to have this command right here that is going to make this starting up the server a way bit easier. It's going to be way much easier. So it's uvcon, and it's going to be uvcon run. Then I'm going to have app main app just like that, and then it's going to have the host as the 0000, and then it's going to have the port as 8000, so it's going to be on localhost 8000, and it's going to be a reload of true just like that, and then I'm just going to import uvcon right here on the top. So import uvcon just like that. So, and then I want to have a print right here, server is running on HTTP localhosts 8000. So this is going to be way much easier when we run our app, because what we have to do right now to start our application is just run Python and then backend dot main app dot main. Oh, email validator is not installed. Run pip install. Okay, let's install this. I'm getting this error, so let's install. So once I have installed that package that was causing an error, let me now rerun the server again. Let me start the server again. So to start my server, because I've created this function right here, I'm going to just have Python the m flag, and then I'm going to have the app main just like that. Let me start my server again. Is an expected keyword argument. Jumping into an error because this is an unexpected keyword argument. No value for argument token URL. So it should actually be in camel case. So I made an error here when defining the token URL. I have made the changes, got an unexpected. So this was a wrong keyword argument. The argument here was token URL in camel case, and I have, instead of having an underscore here, I'm going to have this as a camel case. And now when I run my pym app.main, you should see the server running and starting up, and it should be running in our localhost 8000 just like that. And yeah, my server is now running on localhost 8000. So when I open this link, so I'm just going to follow this link. I'm going to click on Control K, and you can see the message that I have, start as running message. Your FastAPI backend is up and running. We have our server up and running. We have configured our main.py. Nice job. So we now get to define our front end, see how we connect all these together, see how we authenticate a user, see how we store our tokens in our front end, how we use these tokens to make every request. And your front end is going to have basically 4 core responsibilities: the collect credentials, the store and send tokens correctly, we have to protect the routes, handle token expiration gracefully. If you get this right, everything else is UI sugar. Before we write any code, let's log this in. The user visits the login form, the user has to log in, and this is the backend or the login endpoint that we just created. And we saw we are returning the access token, the refresh token, and the access type. And once we have these tokens, we store them in our front end. It can be the local storage. You can store them in form of a cookie. And when now we make every request, once the front end sends a request to the backend, it has to send an access token on every request. And if the access token has expired, we use the refresh token. Now, if the refresh token has expired, the user has to log in again. Now, the front end never hashes the passwords. The front end never decodes JWT for security. And you also have to note that the front end never actually stores any JWT secrets. All of these are in our backend. So without further ado, I'm just going to go ahead and create my Next.js project, and it's going to be simple. So basically this is a React, because Next.js is basically built on top of React. So we are using React for this. This is our React front end, and it's going to be in Next.js. Now we are going to use Next.js because it comes with a lot of advantages that we'll not find in a normal React app. So I'm going to have the npx create Next.js. I'm going to use the latest version. Then I'm going to name my folder or directory the front end. And then I'm going to click on enter. Then I'm going to just wait for this to be set up. The version that I'm using here is version 16.16. This is the latest version by the time I'm creating this video. So it might be a later version, but if you want to work with the same version, you can just copy this. You can just have an npx create next app at 16.16. This is the version that I'm working with. So I'm just going to click on OK to proceed. And then here I want us to go ahead and customize these settings. So right here, I'm going to customize the settings myself. Yes for the TypeScript, and yes for the slint, and yes for the compiler, and yes for Tailwind. No for the source. I don't want to have a source directory or a src directory, meaning source. I'm not going to work with the source directory. I have yes for the app router, and no. And now I'm going to wait for this to install, and I'll be right back to now start the application. Just I'm going to give this a minute to install, and once this has installed, I can access my front end, and I'm going to now start working on my Next.js application. So follow this setup if you want to follow up with me. You can see I'm using TypeScript. I'm going to use slint, the React compiler. I'm going to have Tailwind. I'm not going to have the source directory, and I'm going to use the app router, and I'm going to have no for the customized import alias. Just like that, I'm going to wait for this to install, and then we get started on our Next.js application. I just successfully set up my Next.js application. I've successfully been able to set up my front end. And now I want us to test for our front end. I want us to test whether we have set up our Next.js correctly. I'm going to confirm this by accessing the frontend directory and then running this command npm run dev, just like that. And I should see localhost 3000 right here, the link to the web page. I should see localhost 3000, and I should see my Next.js application running on the localhost 3000. So when I follow this link, I should be brought to this page right here, this landing page. Yeah, you should be seeing this if you have set up the Next.js correctly, if you have set up your Next.js application correctly. I'm just going to clear right now. I'm going to exit. So I'm going to just clear, just like that. All right. So right now I want us to talk about security. And obviously this application is based on security and authentication. Now, when it comes to storing our JWT tokens, which are basically our digital keys to the kingdom and are the determiners of the authentication. They determine whether the user is authenticated, whether the user can access protected routes or not. They are the most important keys we have in this authentication setup. Now, you have to make a decision on where to store your access token and your refresh token, or where to store your JWT keys in general. Now, if you decide to store your access token in your local storage, there are pros and cons to that. And there's also another decision of storing your JWT keys in the cookies. And so right here, you only have two decisions. One, you can store your JWT keys in your local storage, or you can have them stored in your cookies. And now if you were to go to a senior engineer, for example, and say, I store my access token in local storage, they might look at you like you just left your front door unlocked. Why? Because of one specific 3-letter monster. When you store your keys in the local storage, you face the danger of cross-site scripting, XSS. Now, the reality of the web is that modern websites run a lot of JavaScript, analytics, ads, chat widgets, NPM packages. If a hacker manages to slip one bad line of JavaScript onto your page and your tokens are in the local storage, guess what? The game is over. That script can read your storage, copy your token, and send it to a hacker in Siberia. They are you now. So, why are we doing it? What decision are we going to make? Because we are builders and we need to understand the trade-offs. So we only have two choices here. We can store our tokens in the HTTP only cookies, and we can have the access token, the refresh token in the local storage. So the HTTP only cookie is the gold standard. When the server sends the token, it tags it as HTTP only. And this tells the browser, don't under any circumstances let JavaScript touch this. Now, the pro of working with this is that it is invisible to XS attacks, or rather say cross-site scripting. Even if a hacker runs a script on your page, they literally cannot see the cookie. And the con is, it is hard to work with. You have to fight the CORS policies, cross-origin resource sharing. You have to manage CSRF tokens, and you can't easily read user data from the token. That's the only con. Then there's the option to work with the local storage. This is what we are using. And the pro is it is incredibly easy to set up, and it's one of the best decisions when we are building an MVP or an application that is needed to be built up fastly to reach the MVP stage for testing. It is incredibly easy to set up. You have the token, you can put it in headers, you can read the expiration date, and you have total control. The only con is if you leave your computer unlocked or your site vulnerable to XSS, someone can reach into your pocket and take it. So, is our app going to be fully secure if we work with the local storage? No. No, if we are smart. For this tutorial and for 90% of side projects, prototypes, and MVPs, local storage is fine. It allows us to focus on the authentication flow, the login, the refresh, the logic, without spending 3 hours debugging cookie policies. But here is my promise to you. If you're building a banking application, if you're building a medical dashboard, local storage might not be the best idea. You might prefer to work with cookies. But today we are learning to fly. We don't need the heaviest armor yet, we need speed. So if you are developing an application and you need to reach it to MVP as fast as possible, it would be in your best favor to work with the local storage. Keep your dependencies clean and build your thing. So in this tutorial, we are going to use the local storage to have our access token and our refresh token stored. We're going to overcomplicate security. We are going to build the engine using local storage, and this will allow us to see the tokens, debug them, and ensure our login flows work perfectly. To get started with this, we need two things in our Next.js application. We need the API client and the auth context, and that's what we are going to create. So in my frontend directory, I'm going to create a lib folder. And then I'm going to create a new file called api.ts. This is a custom Axios instance that automatically attaches the token from local storage to every request that we send to the backend. And also, this is where we are going to define our Axios base URL. We are going to set our base URL. We are going to set our base headers. And for that reason, I'm going to have Axios installed. npm install Axios, as simple as that. Give this a minute, let it install. I've just installed Axios, and this now is going to be our interceptor. It intercepts every outgoing request and stamps our permission slip, which is the token, onto the requests. So this is our lib API file. And something I want to tell you is that authentication on the front end is not about logging in users. It's about keeping them logged in, even without them noticing. And I want us to define our base URL in this file, our base config headers, and have this refresh the tokens when needed and add the access token on every request. So this file does 4 critical jobs that I want to just mention in a minute. It talks to the FastAPI backend. That's the first thing. This is the base API. Automatically attaches the access token. It automatically attaches the access token to every request, and then it detects the expired access token or refresh token. It refreshes the token if the access token is expired and the refresh token is not expired, and it retries the request silently. If this file works, your app feels professional. If this file is broken, it's chaos. So what I'm going to do is that I'm going to start with importing Axios at the top, just like this, from Axios, just like this. And then I'm now going to define my API, which is going to be Axios. I'm going to have create, open parenthesis, square bracket. We have the base URL, just like that, is localhost http localhost 8000, just like that. And then we have the base headers, which are going to be headers equals to the content type, and the content type here we in this case is the application /json, just like that. Now we have defined our base URL, we have defined our base headers. What does this really mean? You're saying every request in my app goes to this backend and uses this configuration. This is the base configuration. Why does this matter, and why does Axios makes working with the API so easy? It's because we never repeat the URLs. We don't copy paste headers, and we have one place to fix all our bugs when it comes to working with our API. And now I'm going to have the request interceptor. So let me have this right here as the request interceptor. And what this is going to do is that it's going to attach the access token to every request sent to our backend, just like that. So every request sent to a backend that requires our token, this interceptor right here is going to make sure that it attaches that token to the request, and the request is going to be sent to the backend with the access token. So what I'm going to do right here is that I'm going to have my int.py interceptors, and then I'm going to have the request use, just like that. And then I'm going to define my callback function right here, my function right here, taking in the config as an argument. And what you're going to do right here is that you're going to have the token equal to the local storage get item, and right here I'm going to have the access token just like that. Now I want us to have a constant file where we are going to have these strings right here, the access token string and the refresh token string exported as global variables. So to avoid typo errors and getting into errors due to the typing, and you can actually make a mistake typing the access token and the refresh token. So to avoid such errors with the typo and everything, to make this easier, I exported this in a constants.tsx. So make sure you export these two strings. So this is the definition for the access token. This is a variable holding the access token. This is how these two tokens will be named in our local storage. So I'm just going to replace this with what I have defined in my constants.tsx, and I'm going to have the access token imported just like that. So let me import this just like that. I have this from my constants.tsx. So now I'm going to go ahead and check if I have the token. Then I'm going to set this token as an authorization header, config headers, and I'm going to have the authorization header, and it's going to be equals to the bearer backticks. Open this, and then we have the token passed in as a bearer. So if we get the token in any case when we are supposed to send the request and when we're supposed to verify the user, we need to have the authorization headers bearing the token. And remember, we had an endpoint in our backend. We had a dependency file that used to extract the token from the headers. So this is the case that we set the authorization header to have our bearer token, and we do this on every request. Now we are going to go ahead and just return the config right here. And now what is going to happen on the error is that we are going to have the promise reject error just like that. So let me just break this down slowly. A request interceptor runs before the request leaves your browser. Think of it like a security desk at an airport. Every request must pass through it. Without this, you'd manually add headers everywhere, you'd forget it on some request, and bugs would be random and would be painful to find. So with this, token attachment is automatic, centralized, and impossible to forget. So let's now go ahead to define our second interceptor, and this is going to be the response interceptor, and is going to be run on every response. And this interceptor is responsible for auto refreshing our token when the access token expires. So if we get 401 error, try, this function is going to try and refresh the token and resend the original request. So this is a very vital interceptor, and this one is going to be having the API interceptors, response, and then you're going to have the use. Now the Axios responses have two main paths. We have the success path, which is the straight through, and we have the error, and that's what we are interested in. We are only interested in the 401 unauthorized. So for the success, we're just going to have the response return the response. Just like that. You're not going to do that with the path if it's successful. But if we get an error, this is where we are interested in. So I'm just going to have a function passing the error as the argument. And right here, I'm going to go ahead and just define my original request as original request as being the error dot config, just like that. This line is huge. Axios gives you the failed request, its headers, its URL, its method. So now you can fix the problem and then you retry the exact same request. See how working with Axios is powerful? And this is how the magic retry happens. So if we get, let's go to define this. If we get an error response status of 401 and we have not retried the request, we have not retried the original request, then we are going to now set the original request retry to true. So if you have not already retried the request, you are going to have the original request now. If now we are retrying the request once, we are going to have this to avoid infinite loops. So we're going to set this retry to true. Sorry, this not should be uppercase, it should be lowercase. This is going to mark the request as already handled once. Don't retry again. So we are only going to retry this once. Once we get an error with our response, we are only going to retry the request once. And then now I'm going to get the refresh token, which is going to be the local storage get item, and then I'm going to use the variable from my constants, and it's going to be the refresh token, just like that. The refresh token is your backup key. You only use it when the main key, which is the access token, has failed or has expired in simpler language. So fast forward this, what you're going to see me do is get the refresh token called my refresh token endpoint that we just created in our backend, get a new access token, set the new access token in our local storage, and then now try the request again. And now because this time you're going to have a valid access token, we expect the request to go through. Otherwise, on error, I introduced a try catch block and it has a refresh error. And right here, we are going to log out the user if we get a refresh error. And we are going to return an API original request if the access token has been refreshed again successfully or we have gotten the new access token. Then I'm going to close this function by returning a promise reject error. What I'm going to do now is export this as a default API. And if you don't really want to write the whole of this code block, you can always copy this code from my repository. It's public. The link is in the description. Context or our auth context provider, we are going to create a new file still inside our frontend directory. I'm going to call this context. Inside the context folder, I'm going to have the auth context. And then we are going to be wrapping this around all our files, around all our children, and you're going to see how we're going to be working the auth context. I have just created an auth context file. Now, just to note, this file is not about security. And I would like to repeat that this file is not responsible for authentication. This file is responsible for our application state. So I want you to think like this. Our backend identifies tokens and validation, and it does validation. Our Axios attaches the tokens and does the refreshing of the tokens, but the auth context manages who is logged in right now. It is responsible for the user who is logged in right now. And then we have our user interface, which is rendering based on the auth state. So the auth context answers questions like, is the user logged in? Who is the current user? Should we show the dashboard or the login page? Are we still bootstrapping the application? Are we in a loading state? All this is handled by the auth context. It does not store tokens securely. It does not refresh the tokens. It does not validate the JWTs. Axios already does that job, as we just defined Axios, as we just saw for our Axios. So this is a big conceptual point. The tokens does not equal the user state. Tokens are technical, backend facing, and stateless blobs. Your UI doesn't care about the tokens. Your UI cares about the user. The auth context, and I'm defining the auth context. Create this file called context in your frontend root directory and have the auth context inside. Now this file is going to manage our user state, is going to determine the rendering of the UI, and I'm going to paste in the code for this. Again, you can go ahead and copy this from my repository and just paste it in, and you're going to get the whole code base for this auth context, and it's going to be a wrapper around our children to manage our user state, to define our different function, and it's going to make working with the auth functions super simple. For us to be able to work with the auth context and work with these functions that we defined, we obviously have to wrap our application around these contexts. And if we try to use one of the function in the auth context, if you have not wrapped our application, if you have not wrapped our children, we are going to get this error. I'm going to come to my layout file and I'm going to add the auth context and wrap it around the children. So I'm simply going to import the auth context. I'm simply going to have the import right here, or import auth provider, which is within the auth context, which is basically going to provide our context, our auth context, the function that we just defined. And I'm also going to import another important library, which is the toaster from React Hot Toast. Now, in order for us to work with the auth provider and the toaster, we have to provide these in the layout. We have to give the providers, we have to wrap this within our children and to initialize them in our root layout. And I'm just going to change this to next FastAPI out, just like that. And in my body right here, I'm going to go ahead and now define my auth provider just like that. And then I'm going to have the children passed just like that. This is the whole application. This includes all of the code. And now I also want to have my toaster just like that. And now I can save these changes. And now I want to proceed to create my auth pages. That is my login and my register page. And now, before we even create our login and our register page, I've already wrapped this auth provider around my children, and I have initialized the toaster. I have given the toaster provider in my root layout. So I've wrapped my children and have also added the toaster from the React Hot Toast as a provider for the React Hot Toast to actually work within our application. So the code is wrapped within the auth provider. I want to confirm whether this is working, and what I'm going to do is that I'm going to delete everything in this page right here, delete all the content right here, and even the imports right here, and I'm going to have this as a use client just like that. And now I'm going to come here and just have the user So if we are authenticated, we should be able to see a user. Let's test for this. Let's see whether we are actually authenticated. So having this as a use client, remember, for you to work with a hook, you have to declare the use client at the top of your Next.js page whenever you need to work with a hook. So I'm going to simply just have the JSON, and then I'm going to stringify this JSON stringify, and then I'm going to stringify the user just like that. So if I have a user, we should see the details, or we should see null. So I'm going to clear this terminal once more and just run npm run dev, and just to confirm whether our auth context is working and our provider is really working, and our Axios is well configured, our API is well configured, whether we are fetching we are getting the token from the local storage, whether everything is set up as it should. I'm going to test for this, and if I have a user, I should be seeing the details of the user, else I should be seeing null in my browser page. So I'm going to open the link, and there you see we get a null, meaning that our auth provider is working as it should work. We are getting the correct message. It should be a null because we have not logged in, we have not created any user. So we are now going to go ahead and create our first user, and actually we should be seeing the user. We should be able to fetch the user. We should be able to have a protected page, and we should be able to log in and sign up. Let's go ahead and now work on our auth pages and our dashboard and our home page. The engine is running, our auth context is ready to handle the heavy lifting. Now we need to build the dashboard, the UI, and the auth pages so our users can actually drive the car. To do this, I'm going to get started with creating the register page. And this is the gateway for our new users, and obviously also going to create the login page, the front door for our returning users. So to do this, I am going to go to my app directory. In my frontend directory, in my app directory, create a new folder, and I'm going to have it wrapped in parentheses. Now remember, working with Next.js, we are using the app router, and for the app router, a file is usually a path to a page, but right here we are going to have this wrapped in parentheses so that our Next.js can ignore this as a route, and this is going to be a group of similar pages. So I have the auth wrapped in parentheses, meaning that this is not a route. The actual route is going to be these two folders, the register and the login. So I'm going to create the register folder and the register page just like that, and then I'm going to have the page tsx just like that, and allow me to paste in the context for my auth page, for my register page. To also paste in my login page. After pasting my register page, I'm going to paste in my login page as well. I'm going to post both of my auth pages, and once I've pasted these pages in, what I'm going to do is that I'm going to test for the creation of our first user. So once I paste in both of my auth pages, I'm going to run npm run dev and have my localhost 3000 running on my browser, and then I'm going to try and register the user. So this is my simple minimalistic register page, and you can see just a simple form to have the email and the password. And remember, when I be filling in these details, I will be sending them to our server in the backend. So here we are testing for the full stack application in general. We have to get the email and the password, and then we have to send these to our backend server in the FastAPI to create the user in the database. And then we have a combo function that is going to not just register the user, it's also going to auto login the user on register. Now, just a disclaimer, if we were using if we had to verify a user using their email, I would not recommend having the auto login method. But because we are not sending a verification email, we're just going to register the user. And once the user is created in the database, we automatically register them. because in this tutorial we are not verifying the user through sending the email. We are just going to have the auto login, and once the user gets created in the database and the entity is created successfully, we log the user in. So I'm going to test for this, and in order for this to work, we have to make sure our server in the backend is running. So I'm going to open my terminal, and I have accessed my backend. I'm not in my front end directory like this one right here. This terminal right here is working in the front end directory. In this terminal, I've accessed the front end directory, and in this terminal, I'm in my backend directory. So take note of that. So I'm going to have the py, and I'm going to just run my main.py. So then I have my server running on localhost 8000. So this will enable me to make a request. So when I make a request, I will not get an error, because if you fail to initiate your server, you are definitely going to get an error and you're not going to be able to make the request. So make sure you have your server running on a localhost 8000. So right here, I also want to open my inspect window to see what is going on. Just make it a little bit smaller, just like that. And I'm going to just have an email and a password. And I'm going to click on the register button. Registration failed. Why did it fail? So we bump into an error trying to register our user, and it seems like nothing is happening on the network tab. There is nothing that is happening. And I think I know exactly what the issue is. So coming to my page, to my register page, coming to my register page, we can see that we are calling the register function, and I want us to go to navigate to the register function in our use auth. So I'm going to come to my use auth, to my auth context file, and you can see what we are calling right here. So in my auth context, I have an endpoint to register the user, and I have the API post auth register. Now, we are not supposed to be making this request to the backend with our base API. Remember, this base API is always attaching an access token when we make a request, and we configured this in our interceptors. So this base API that we defined right here is specifically for making requests to protected routes and routes that required an authenticated user. For our register and login route, we are going to simply have this API replaced with Axios, and we are just going to use the normal Axios. So I'm just going to delete this API, and I'm not going to delete the API, because you're going to need the API when fetching our users. So I'm going to replace this API dot post with Axios post, just like this. And then now I'm going to define my URL. I don't have a base URL, so right now I'm going to define my URL just like this. And now I'm calling this directly with Axios. I'm not using my base API, because my base API is meant to configure the headers to include an access token, which we don't have because we have not created any user or logged in. Same thing I'm going to do with my login. Change this from API to Axios, just like this. And then we are going to have HTTP, and then we are going to call this directly without using our base API 8000. So if we call this URL right here, if we call this directly with our Axios without having attached an access token, the backend should not bring up an error, because we don't require to have an access token to log in or register. We don't require an access token to create a user, this should be open to any user whether they are authenticated or not. So this is not going to bring an error. When creating a user or logging in a user, we don't require the token, we don't require authentication. And with that, I'm also going to come to my backend, and in my database.py file, seems like I made an error, and it seems like I had a typo when defining my async session local. So this is not supposed to be expires on commit, it's supposed to be expire on commit. We don't have the S. I'm going to make the change like that, and this should solve the error for our backend. And now what I'm going to do is just run the pym app.main and rerun my server in the backend again. And I'm also going to run my server in the front end again. So I'm just going to exit and clear this and then run my npm run dev, have my localhost 3000 running afresh. So after fixing the few errors that we were encountering, I want to now go ahead and register the first user, and hopefully this user should be created in the database, and we should get a new user registered, and we should have an auto login. So I'm going to click on the register button, having my network tab open, and let's see what is going to happen. You can see now I'm calling the function. At least you're seeing some activity. So our registration has failed. Let's look at the error we're getting in our console, in our terminal. And I get this error from my backend server. And this is an error to do with the hashing. You can see that the password cannot be longer than 72 bytes, truncate manually if necessary. This error is being brought up by our bcrypt library. And so to solve for this error, we are going to do this hashing with two layers. We are going to implement the SHA-256, and we're also going to be working with bcrypt to do the hashing. So we now do the hashing in two layers. What do I mean by this? Let me just paste in my file, just like that. And now I have a pre-hashing with SHA-256 to normalize the length, and then I generate a salt and hash with bcrypt, and then now I return a string for the database storage. So it might seem a little bit intimidating, but I just want to explain a bit what is happening here. So the error we are getting that we cannot have passwords longer than 72 bytes. This means that bcrypt ignores anything after 72 bytes. So long password can be silently truncated, and that is dangerous and non-obvious. Our solution right here is to pre-hash with the SHA-256 and feed a fixed length result into bcrypt. So when we pre-hash with SHA-256, it gives us a fixed length for all our passwords. This ensures any password length is supported. Bcrypt always is a safe input. Security properties remain strong. So at the top here, we are importing bcrypt and hashlib. Hashlib is Python's built-in cryptographic hash library. And then you have bcrypt, the industry standard password-based hashing algorithm. Then we have the function to hash our password. This function runs during registration or the password updates. So this is a function that runs every time we register a user, and it usually takes a plain password as an argument and returns a safe string to store in the database. Now you can see right here we are creating our password hash. We are pre-hashing with SHA-256. This password hash, as you can see, is being passed through, is calling the hashlib SHA-256, and the password encode right here converts Python string into bytes. Cryptographic functions only work with bytes. That's what you have to note. And the hashlib SHA-256 applies the SHA-256 hashing, one-way, deterministic, and fast. And we have the hex digest method right here, which converts binary hash into readable hex string. So the output right here, one thing you have to note that every time we run this, the output is always going to be 64 characters for all the passwords, no matter how long the password is, 5 characters, 50 characters, 500 characters, and that's the magic of working with the SHA-256. Result is exactly the same. Password remains to be 64 characters. And this is going to eliminate bcrypt's 72-byte problem, like we're being told here to truncate this manually. So now we're going to eliminate this error and we should save our user. Finally, we go ahead to generate the bcrypt salt with the bcrypt gen salt method. This generates a random salt. Salt is unique per password and it prevents rainbow table attacks, identical hashes for identical passwords. Bcrypt automatically embeds this salt into the final flash. And now we have the hash, which equals to the bcrypt hash password, and then we have this password hash, and then we encode again, and then we have the salt. So this basically password hash encode, this right here basically converts the SHA-256 hex string back into the bytes. And then now we have this function, the overall method, which applies slow hashing, and now it includes the salt, cost factor, secure comparison, resistant. Bcrypt is intentionally slow. This makes brute force attacks painful. And now we return the hash password decode, and then we have the UTF-8. Why does this matter? Because bcrypt returns bytes and database stores string. Decoding make it easy to store in our PostgreSQL in our database. And now we are going to have the final output as a string that is able to be stored in our database. We also have this verify password method, and this is going to be run during the login. Now this method takes the user input, compares it against the stored hash password, and then it returns a true or a false. Now it applies the same SHA-256 pre-hash that we used during the registration as we were creating our hashed password. This step must be identical to the registration, and the reason for this is because bcrypt compares hashes. If pre-processing differs, login will always fail. You are creating the exact same 64-character SHA-256 output. That's what we see in this method right here. And then you're going to return the bcrypt check pw, which means check password. What the check password does internally, it extracts the salt from the stored hash, applies the same bcrypt cost, compares hashes in constant time, no timing attacks, no manual salt handling, and secure comparison. And that is it for our security py. Now these functions, the verify password and the hash password, are going to do the job. They are going to produce the 64-character output. They are going to compare the passwords. They are going to hash the passwords correctly, and registration for a new user and login should work. Just while we are at the backend, I noticed I made a very silly mistake when it came to defining my JWT algorithm. We don't have a H256. What we actually have is a H6256. So this was a typo error that I made. I'm going to save that. So go to your config settings, change the JT algorithm. If you had a H256, change it to HS256. This is the algorithm. There is no algorithm named H256. My apologies. So now we should go and test for our user creation or our user registration. I want to do some small debugging on my front end. So these are some mistakes I made on the fly, trying to quickly have this all set up. They are small bugs, very tiny bugs that might cause um, you to search for hours, but they are very small bugs that I made, some small errors that I made. Right here in my constants, I just define the constants. What happens when I just define the constants and I hover over this and a value we have assigned, it says the access token is assigned a value, but it's never used. So it means that I have to export this to use this in my files. So these are my variables. These are my variables for the access token and for the refresh token, and we are supposed to be using this throughout our application. And immediately I export the access token and the refresh token, you can see the red lines in my auth context and in my API, because now I need to import this. So I'm going to import the access token and the refresh token just like that from my constants file. And once I have these constants imported, now I have the green lines. I no longer have the red lines. I no longer have the errors. And also right here, what I'm going to do is I'm going to have my imports. So I'm going to import the refresh token and the access token from my constants file, just like that. My access token, just like that. Now I have this saved, and now I want to run this again. So I'm going to just click on Control C, and I'm going to shut down the service, and I'm going to run npm run dev. And now I'm going to have my, now this should not be the backend. So for the backend is going to be the running the main file, the main.py. So it's going to be main, and then I should have my FastAPI server running. And now for the front end, I'm going to shut this down, and it's going to be the npm run dev. Now I want to run the front end service again, and I'm going to shut the previous service down and run this again, npm run dev, to have my Next.js application starting afresh. And now when I navigate to this localhost 3000, I should be still having a user data null. I should not be having the data, and you can see immediately I'm redirected to the login page. Now before, we did not have this redirect. We were not redirected when we were landing on our homepage. But now with the auth context, we are being redirected to the login page. And so when I now create my user, I'm going to open the inspect window, and I'm going to have the network tab open. And now when I register, I log in my user, you see, okay, this is the login page. When I try to log in a user, I get the invalid email or password, because this is the login page. So I have to go to the register page. So now when I register a user, we should see the auto login, and we should see a status of 200, meaning that the user is registered, and a return. And now we have the toast, and we are being redirected to the dashboard page. And you can see we are hitting the user's me endpoint, where we are fetching the details for the user. I have the ID of the user, I have the email, and the is active as I expected. That's okay. Now what we're going to do is we are going to create a simple dashboard page, and now we'll have our full authentication system set up for our Next.js and our FastAPI. Nice job if you have reached this point. Our simple dashboard. Let's have our simple dashboard. We're going to have a simple dashboard in a folder in a routes. I'm going to have a route group of protected routes. So I'm going to have this group for protected routes. Remember, for Next.js to ignore the path, we need to have this folder or this directory in parentheses, and then I'm going to have a new folder inside here, or a new path. And this is going to be my dashboard, just like that. Then my page. So this is going to be my dashboard page. What I'm going to do inside my dashboard page is I'm going to paste this simple dashboard page that I have vibe coded, to be honest. And it's a nice page, a simple page. But the most important thing that I want to show you here is the bounce logic. When we have no user and we are not loading the user, what you're going to do is you're going to push the user to the login page, and you're going to have these as dependencies for our use effect. You're going to have the user, the is loading. So if any of these states happen to change, then we check whether we still have the loading. If we are not loading, then and we don't have a user, then we are immediately pushed to a login page. And if the page is loading, we have this nice text display of loading our data, and then we're going to display our data. We're going to have a sign out button. We're going to see how all this comes together. And still in my home page, I wanted to note that I have my use auth in my home page. I'm still using my use auth context in my home page, and I'm still getting the details for the user. So if we are logged in, we should immediately see the user details even when we hit our home page. And just for that reason, let me have this npm run dev. I'm restarting my server in Next.js again, and for my backend, I also want to restart the server. So I'm going to shut this down, and then I'm going to have my server running again, and it's going to be the Python main, the main file. Let's run the main file, and this should start my backend server. I should start my FastAPI backend server just like that, and I'm going to follow this link to open the page. And now let's see what we'll see when we land on our homepage. We should be seeing the user details if we are still logged in, and I get user details of null. There you go, I get my user details. So I have restarted everything, and at first we saw that we had a null, which meant that we were not authenticated. And then after a few seconds, we see the user details. What does this mean? So if we had a loading state, we were not supposed to see the null. We would have seen a loading message, and we would have seen our server or our auth context loading the user. Now, we have not implemented a loading state in our home page, but you can surely see that you're getting the details. And this is what you're interested in. Now, this confirms to us that you're logged in. So when I navigate to the dashboard, I should see the loading state, and I should see my dashboard just like that. And I have my user ID, my email address, and my account status of active. Now, this is what you should be seeing in your dashboard page. Now, if you want to copy the dashboard code, you can go ahead and copy the code from my dashboard page and just paste it in, and have your dashboard page showing you this. Now I want to click on the sign out button and see what is going to happen. This should call my logout function to immediately remove the access token and the refresh token in my web page. And just to confirm that, I want to navigate to the application tab in your inspect window, and you should see the access token right here. When you click on this localhost, when you click on this drop down arrow, and let me widen this a bit. So when you click on local storage and you click on this drop down arrow, you should be seeing your localhost 3000, and you should click on that, and you should see the access token. Now what happens when I click on the sign out button? This access token should disappear just like that, and now I'm immediately redirected to the login page, meaning that everything is working and our auth system is complete. Now what I want to do in my home page is I want to go ahead, get rid of this use auth, get rid of everything, and now when we go to our home page, we should be immediately redirected to the dashboard. So I'm going to import the redirect. I'm going to delete that. Then I'm going to delete the use client. I'm going to import the redirect from next navigation, redirect from next navigation. And then what I should be returning in my home page will be a redirect to the dashboard page, just like that. I'm going to save the changes. On running my Next.js application, again, now when I follow this link, I should be immediately redirected to the dashboard page on landing, and you can see now I'm redirected to the dashboard page on landing. So when I sign out, when I log out, and now I sign in, immediately I'm pushed to the login page. And even when I come to my network, my application tab, you can see my access token and my refresh token right here. I have the access token, and this is the value for the access token, and I also have the refresh token. So meaning I'm fully authenticated, I'm getting the refresh token and the access token. And when I sign out, you can see that I have no access token and a refresh token. But when I sign in once again, I have the access token and the refresh token. Nice job. So everything is working out, everything has come together, and our authentication system is set the way we expected. And you can see this, I even have the state for the user in my application tab. Congratulations, you've come to the end of the tutorial. You have created your full login system being handled by FastAPI using the JWT tokens, storing your JWT tokens using the local storage in your frontend. You have finished your authentication system, and you can use this to create your MVP, work on your SaaS, work on your project. Congratulations. Now, I'm not going to deploy this. I'm not going to go ahead and deploy this application. This is not going to be part of the tutorial. But if you want to see me deploy the application, if you want to see how we can have an authentication system and have email verification by sending emails to the user, make sure to comment, make sure to like the video, and if the video reaches 1,000 likes, then I'm going to do a tutorial showing you how to create an authentication system with email verification, and I'm going to show you how to deploy this on Render and Vercel. That's the end of the tutorial. If you found this to be useful, educational, and you learned something, make sure you like the video. See you on the next one. Follow and subscribe for more content.